sound? Are you hearing? Can you hear me? No, it's because we are next to each other.
Testing. Testing 1, 2, 1, 2, testing. Very, 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 very good. Thank you. Very good, very good. Audible. Thank you. Hey, it looks sophisticated, my brother. What is this? What are all these, man? What is streaming? It's streaming like that. Wow. This is technology. All right.
Adi. We did exactly what you told us not to do. Ati?
Thank you. Does this pay for it? You might need to.
Now, I didn't want to tamper with because
Oh, you're saying as a contractor? No. That's for sure. You check up at 2:30. So, I also did. I did that few. That should be coming from the side, not.
so I was trying to. Yeah, I can see that. The same thing that comes from the last one. Yes. Actually, it's not enough.
Yeah, and then that protection. The whole taking works.
I'm about to give a concert.
Sue me.
I was joking. I'm broke.
Check. I've been asked to open our session this afternoon by what I read. And I think we should start moving on. So good afternoon, everyone. I won't say much, let me do what I'm supposed to. That's it. Father in heaven, I'd like to thank you for this day. Thank you for congregating us here for this session. We ask that we may be able to pick from what we hear and that it will be beneficial to us. We ask that you be with us and guide us in Jesus' name. Amen.
Good afternoon, ladies and gentlemen. Thank you very much, Chairman Emeritus, Mr. Ken Gedenji, for opening this session with a word of prayer. I would like to thank all of you who have made it this afternoon for this industrial professional talk. And I hope that by the end of the session, we all have something to have gained, learned, triggered or tickled our interest or curiosity, and even for our young people who have joined us today. We hope that you'll be able to get something that you can do in addition to what you're doing. I would also like to thank Mr. Michael Gedenga, who is the keynote speaker and also the sponsor of today's Guzi. Without further ado, I would hand over the session now to Michael to take us through and tell you 2 hours. May we give him a round of applause?
Thank you, everybody. So, our talk today is just to kill time before the main event. So, now, just let me. So the topic today is architectural acoustics. Now, it is one of the things in my life where I've been accused of making up a profession. Because people wonder, what is that? Does it even exist? So we're going to look at this talk. It's a brief talk, 4 segments. 1, historical insights. What's the history behind this thing? 2, we look at the science. 3, relevance. And finally, Q&A. So each of these will be about 15 minutes. So we should be good for Nyama the next 45 minutes or so. So I want to start you off. First of all, just defining architectural acoustics. It's about the behavior of sound in space. So let's not dwell too much on that, but it's good at least to have a definition, because now the definition becomes a lot clearer after. Because as I've said, a lot of people ask, what is this thing you keep talking about? Architectural acoustics. So we'll not dwell on this. We'll go to the next slide where it gets interesting. So there are some people here who have no idea what these are, and then there are legends who are here, who are full of nostalgia. So a lot of things have happened, as you can see. Ideally, 1877 is acknowledged as a time when people started recording sound. So you have an event like this, the recording of sound from an event. Now that had a very big significance, because first you'd go to any event, whether it was a ceremony or whatever you went for, you could not carry that sound, you could not recreate that sound. So a lot of what was going on during all these developments is, how do we create a format where we can record the sound for playback later? So it started off with all sorts of very mechanical. You had the gramophone, and you had reels. The thing now that started becoming familiar is now like the compact cassette. Now that, I think, for a lot of people who interacted with that, this was an important milestone. But the key thing was recording sound for playback. Now, we have two formats here. Here's the cassette. There's an interesting gadget here, which I know many people did not interact with. There was a laser disc player. There was a laser disc. It was very short-lived. Worldwide, only 4 million were sold. So it was a failure in terms of from a market perspective, but it was a very popular thing. All these transitions were limited by how you can record sound, how much the medium can carry. And this was a switch now to when you started having magnetic tape from analog to digital media. So that the biggest challenge all this time was the sound occupied a lot of, all these formats were trying to increase the capacity. How much sound can you carry within whatever format? So this then became the major frontier. I know again here for the legends, you will know there are things called the Dolby noise reduction. You know, those are things like Dolby noise reduction. What happened was that first and foremost, when we moved to the magnetic tape, it came with a lot of hiss. They used to have a lot of hiss. So these players came with, there used to be a button for Dolby noise reduction. And this Dolby noise reduction, there was a company called Dolby Studios, run by somebody called Ray Dolby. Now Dolby was now finding out that there was just the way sound, the human ear can tell the difference between very loud and very low sounds. You can compress the format because you eliminate sounds that the human ear cannot really tell. And that's where Dolby noise reduction came from. Now, how is it related to this? Because we have still not gotten to architectural acoustics, but this is the beginning when they started realizing your initial formats were mono, but the human has 2 ears. And the human being, because of those 2 ears, you are able to pinpoint things at very, very accurately. And that started making these guys interested that, you know, apart from using that thing for compression, why don't we try these formats where for cinema, I can put speakers in a way that now my ears can be fooled. Yeah. Where the sound is, and that's now, it started off from the noise reduction, from the Dolby noise reduction. Then we started Prologic. Before that, there was actually another format called quadrophonics, early 70s, where they were putting 4 speakers, but this was now more towards cinema, where they determined that if you put speakers behind somebody, you can start recreating the space. And Ray Dolby was doing all this research. Then came a man called George Lucas. So George Lucas, in 76, produced a movie that is a legendary movie also, Star Wars. And when he went to watch that movie, he was very disappointed by his own. In the theater, he just said, this is not a, with all the work they are putting, he was not impressed. So what he did, he went, first of all, teamed up with Dolby, and explained his problem to Dolby. Then they talked with a person called Tomlinson-Holman. THX stands for Tomlinson-Holman Experiment, where they said, 1, we have equipment we are using to create the movie. That's one area. Then we also have the room where the movie is being played. So the first THX certified theaters were about both the equipment and the room. Now you can see where we're getting. They realize the room has a very big impact on what you're hearing. And the first movie that came with this THX, the first release was Return of the Jedi. That was actually a movie built developed for THX, but also it meant the theaters had to be also THX certified. So now we are beginning to see that architectural acoustics, so that's why I'm driving to the realization that the room has as much impact as the equipment. So that is the journey when you start hearing all these formats, and by the time they're coming to be digital, they found the minimum number of speakers to completely fool you was 5.1. Center speaker, 2 speakers in front, and 2 behind. That is the minimum. Now you have 7.1, 9.1. Those are just additional. But now that was computed and found. With that kind of setup, the human being cannot tell completely. And if you watch those movies in 5.1, you're completely fooled. That shows you the impact of the room, the technology and the room. So, what is the science? You've got a room like this. The science is, what are you using the room for? For every room, the idea behind customizing the sound to a room, one of the biggest and the oldest practitioners of this were the churches. The ancient churches, the Romans, they actually practiced or are very aware of acoustics, but not clear. So they took advantage of it. And they started finding that now, if you are in a church and the sound stays for long, it makes you sound holy. It is actually deliberate. So in the old churches, they would have reverb. Reverb is how long sound takes before it dies away. You'd have a reverb of 10 seconds. So when somebody talks, now you see it sounds mysterious. So it was actually let down, said, okay, this is okay. But as they moved on, they improved. Because the problem with when the reverb is too long, it also now interferes with the speech. So reverb became a very big, those are some of the very big areas. So it is old in its the recognition that there was something about reverberation, it was always there. But about controlling it was the late 1880s. Somebody called Sabine came up, actually now sat down, and those people did a lot of work, calculated and found there is a way to determine what the reverb in a room is. So when you have a room of this size and you want to say, what is the purpose? Is this room going to be used? Is it a disco? Is it a, whatever the use is, there are certain reverb, recommended reverb, and it's in seconds. Reverb is the total time because it's how long does it take to die down. So you find that there are churches, I mean, there are various, like a classroom. The amount of time in a classroom should be 0.6 seconds. Otherwise, it interferes with learning. If you have a classroom with small children who are very easily distracted, it should be 0.4 seconds. Okay? So I'm starting with the classroom because that's an important area. Classrooms were one of the areas which have in recent times, 20, 30 years, people have realized this is very serious because it affects learning. And how does that affect learning? If you've never heard well, you don't know, you don't hear well. Yeah? So you have a child who maybe has a problem, they have an impairment, but because they've never heard well, they cannot tell. Yeah. So because of that kind of problem, there are some very strict regulations in a lot of countries around the world. So what I'll do as we continue talking, I'll just have something passed around so that you can flip through as we're talking to see how serious this is. So now this is something called Design for Schools, building built in 93. Any school in the UK, if you do not conform to this, you do not even get an approval. You cannot break ground. So there are various, there's a lot of legislation like this. New Zealand, Australia, Japan, each of them have their very strict conditions. What are the parameters so that you make sure that people are learning? So That is one. Just flip through it. So you can also see it is not a made-up profession. It has very serious consequences about not conforming. Then you again, when you look at the science, churches, I mentioned churches earlier, but churches are actually some of the most complicated places to have an acoustic design because of the use in a church changes. What at one point in the service you have the Mobiri is talking at the front, another one you have the choir, then so you have it's mixed mode. That is one. Two, it depends on the type of church. Catholic, Anglican, and PCA reverb is 2 to 3 seconds. Pentecostal is about 1 second. Where you have a lot of clapping, a lot of drums, the lower the. So even when you're doing a church, it has to be specified what is the. So it becomes very complicated. And then you see now a church starts introducing, and you see a lot of the older churches had organs. The cathedrals, the basilicas, all of them had organs. So it has organs need that 3 seconds. So all this apart, when we look at the science, is to see it's actually a lot of there's a lot of science behind this. Another area which is very important is you found out that the place has an issue from an acoustics perspective that we can property of absorption or blocking. What is the problem we have here? We have no controls, and I have here Kano that KEBS. I used to say now we don't have any. When we are doing any project right now, we do not have anything that is certified as acoustic. The acoustic properties are not certified. So when I'm recommending something to be put in a place, we don't know whether it is actually something that is certified. So there's a lot of science in this. A lot of science in this. And so it spans from architecture to engineering. There's a lot of areas that there's a crossover. Again, just showing you these are the kind of it's a highly mathematical career. Now, how did I stumble onto this? First was the interest, but I'll now share a story where there was a time when I always had the interest in the sound, but many years ago, there was a club that was closed called Coco Beach, Buruburu. And the architects on site were triad. And the person from triad, one Joe Mutuku, who is here at Chikelgeta, they were told they guarantee that if the repairs are done, the acoustics must work, because they were shut down by Kaguti, who was a PC. And he was their friend, but he said, now Buruburu Welfare has made a case, you have to sort it out. So of course, it could just be now, is this something you can do? I was at that age where you say, yeah, that's something. Of course, I've never even done, I had no idea what that was, but I said, Bora, deposit. I think a deposit, then then we can talk. Don't talk without a deposit. So I asked for a deposit. I think it was actually something like 20K. But so get me the deposit. I bought a book. This book I still use up to today. So, so from about 10K, brought to 300K in its first. So today it's still there. And unfortunately, still today, there's still no structure around acoustics. And that's one of the things that I was saying, a primary reason for this talk, apart from meeting Yama, was to create awareness so that we create, when I know someone like Chair, one time emeritus, every time somebody comes and tells me now there's a church being built, but it's too late. The work is supposed to be done at design, but there's no knowledge even at the university. No, it's not known that this is an entire career on its own. It's a branch of architecture. It's under architecture, but now it's a very specialized area. Yeah. So we are saying that without this awareness, when roads are being built, for instance, our highway code, for the highway, there's no mention of acoustics. Out there in the developed countries, you cannot build a road if you have not put what measures are you going to put so that you're not disturbing? Yeah. In Kenya, we have the building code. It does not mention acoustics. Building code 2022, there's no mention of acoustics. So you can see where the problem is. Yes. And yet, look at the kind of careers that are out there. It's a very big, very big area. All these are related to acoustics. Even when you have those events where you have people, sometimes you find these top performers will not come to Kenya because they don't even have the people who can. It's a very, even within acoustics, there's a lot of specializations. Lot of specialization even within that, but it is not touched. So this awareness is hoping that everybody knows somebody who will now start saying yes. And the other thing is that the younger people here, this is an area which is completely untouched. When I say untouched, it means when I bill, I pick a number from my head. There's no competing estimates, is what you say. So for the people who, because we have now the younger people who are wondering what are the opportunities out there. This is an area that is good to know exists. It's a very specialized area, and eventually it has to be addressed. When you start hearing Mosiria closing clubs, that's acoustics. But even they are lost. They close the club, but they're not sure why. And it's a circus. Nobody's very clear what exactly are the regulations. So because we don't have that looked at as a career, then we have a problem in legislation. The other thing that suffers from there is training. Because of not recognizing it, here is a very sad statistic. Out of the top 20 universities that offer, first of all, you'll not find it outside South Africa or North Africa. Out of the top 20 campuses offering acoustics in Africa, and remember I said there are none outside the north of South Africa. 9 are in Egypt, 8 are in South Africa, out of the top 20. Okay. Now the top one, Cairo University, is number 461 globally. That is where we are. So now I would like to hear. Still too early to go for Nyama Swag. As I told you, you also have to participate. Yes. Yes.
Quick question.
Yeah.
So what you're saying is that this is actually a substrate of architect. So if somebody like he wants to take the history and study it,
Yeah.
talk about Cairo and all that.
Yes.
So he comes out of there with a degree. So can he be an independent consultant or will he be absorbed by an architect?
As an independent consultant, there's nothing to stop you from getting your training to go as an architect.
Maybe I'm not confirm what Mr. Elijah has been talking about. I'm an architect.
Yeah.
a typical architect take 5 years in college. Now they take 6. I think, 4 years they do get a bachelor's, and then you do architecture or whatever. And then, but even now, currently as we speak, just to reiterate what Jackie has just been telling, the unit called architectural acoustics does not exist. I went through my 5 years, they're going through their 7 years now, but they don't get any.
So what that means is that that person can be injected into a architectural farm.
Yeah. So what we're saying is that this is virgin territory.
Correct.
Underline the word virgin. This is
Please
virgin.
use the word green.
It is virgin territory, and I think it's an area of great opportunity that is has not even scratched the surface. There are numerous cases whereby you build whatever it is you build, architecturally it stands, but it is not usable because of renovation, because of this, because of the other. There are clubs all over the place where you cannot, when you sit, there are bars you go to where you sit and say, I can't sit here. Turn down the music. What is it to shout at whoever? Turn down the music, because we can't speak. And we came there to speak to each other. So those are all opportunities. And in terms of formal learning, I don't think opportunity exists in the country. It would have to be some online program or something or the other, or some other place. But then the polling that will have to be set up so that you have a body, an institution body which certifies that body. So it is when I say banking, I have to be, there's no structure.
So Jackie,
But there's a need. The need is clear and it's getting it.
yes. Just to add on that, because the young guys are here, and even for those who are parents, what is the background that you take you towards acoustic engineering? Are you going to, what do you need for concentration? Are you a mathematics student? Of course, it's STEM.
It's maths and physics. A lot of maths and physics.
Yes. For the person who's practicing.
So, yes, it's one of those fields where you still have to go back to your maths. There's no running away.
The way I see it, is more of mechanical engineer, for instance, we really are building something engineer. Yeah, so he does building services and everything. So if you specialize in this, very easy because there's a basic math and physics behind all this. So this is now just applying. So it would be very easy. Married also with an architect who now also have the concept of what they understand the basic law. Because the architects have to do like basic engineering. So the building stand, we have one, they have to have that basic engineering. So it's both areas, architecture and engineering. So it's more, I think, of a specialization path, either at a master's level or even PhD level, I would say. Because you're already a mechanical engineer, then you can now go and get 6 months, 1 year specialization, then come and take another 50.
Thank you. Yes, coming from some knowledge of standards, and standards generally are developed by industry people themselves who voluntarily come together. Why is it that there has been no move or demand to get people together, then go to Kenya Bureau of Standards, set up a technical committee, and put in place some standards? You can even start by adopting other people's standards and then develop your own. Why is there a lacuna there? It's not important.
I can only guess. My guess has been, remember this whole genre is under architecture. And unless School of Architecture, that's where this whole, because it's not owned by any particular group, discipline, like it's under architecture, then I would think maybe, but at this one I'm just guessing. I'm just guessing. Yes.
Yeah. I go to Google. There's to study acoustics, you can pursue various academic paths like physics,
Yes.
engineering,
Yes.
or architecture.
Yeah.
Or specialized through postgraduate degrees in acoustics. Yes. Then it says here's a more detailed breakdown. Academic foundations, undergraduate degree, postgraduate degree, mathematics. So from what I'm seeing, it's actually a course that is only that has we have limited from, but it's a course that is you can pursue from
Correct.
from any angle as long as you say now I've done engineering.
Yes.
I've
Correct.
done physics. Now let me get you.
That is correct. That is absolutely correct.
Mine, as a consumer, I can't say I go to school right now and I correct what I've been. Out of the observation in my village, had a different, a house built with bricks, these normal blocks. In the rooms, you always find there's always different kind of behavior. In a bricks house, where that particular bricks, someone in that building is talking, can easily hear these are the end.
Yes.
But once done with blocks, it's minimized.
Yeah.
Now I'm looking at since me, I've already, made a mistake. How do I correct it? So that, I like my bedroom, my room emerged.
River, we want like actually.
One good hope. And the doors, can you also see the doors in the
No, that is actually now. Number one, that's a good observation because you see when you're talking about the construction materials, you find that like I'll mention the US or North America. North America, a lot of houses are built with drywall, not stone. And drywall, so you have gypsum board, then you have in between some space, not space. Now they put some acoustic material to try and block. Here, yes, here when we have stone, here you have stone, and then to tell how you can tell this is that you'll find in the specifications of your Wi-Fi router don't work in Kenya like they're supposed to work because here you have stone. So you'll find there are rooms in your house that don't get Wi-Fi because we have stone. So when they're saying that this Wi-Fi can boost around, that's one of the things that affects. So the same thing now with sound. Now you've already built. You can actually put acoustic panels to block. Then the acoustic doors. That all those can be done. But what they say earlier that these things are best done at design. The cost is put it up. Remediation is actually expensive. Because now you're going to buy, you already spent the money on whatever you have to put. Now you have to, if you want to put windows, you cannot just come and put another window. You want acoustic glass, you have to replace whatever you have put. So like there's a school project I'm working on right now. We're having to replace glass, doors, acoustic doors, and it suddenly become quite a large project for them. And of course, this is a school where they just completed the project last year. It's very painful for the funders, the parents, and everybody.
Is it also applicable in hospitals?
Extremely. In fact, hospitals, that is a major problem. That's why we're saying that this whole collapse, and I think what Agri was asking is a very pertinent question. Because this is a very serious problem. I mentioned, I think you remember the call at the time when I had a knee surgery. And I put up at Nairobi hospital. I had to leave the hospital because of noise. I actually left the hospital and I went to 4 Points. Because I could not, from 4 a.m., the matatus from Gong are very clear. You could hear them every day, and you can tell even which matatu it is. So, and for me, my problem was my leg. So I said there's no other reason for me to stay here. And the doctor agreed. He just said, don't go home because you can fall again. So it's a very serious problem. Like for a hospital, that is a serious issue.
Jackie.
Yeah.
So you said to remedy would cost more. Also, of the way you guys charge also. There's no known standard. So what I'm trying to get at is that what would be the difference if someone is building a house? Yes. To have the design of the architect draw something that is acoustic engineering friendly, as opposed to remedy stone wall, EPC.
But actually the thing is this: the additional cost doing it at design is very marginal. Yeah, because if you're going to buy, you have to buy, say, you say that there's a place where you want like say a glass, some acoustic glass. Yeah, or you're putting up like now a lot of people have home office. Where you put your home office, if you do not put it in at the design stage and it's next to the TV room, you see those are things that are, or at a design level, they are very easy to move around. The problem is when you put it up, then you find now that you've got your teenager who is practicing with a saxophone. Now the house becomes uninhabitable. Because now, and you're the one who has paid for that device. We confirm that. Those are some of the challenges. Those are the design stage. You sit and design, and you sit with the architect and say, first of all, let us look at the implications. It is much cheaper. So the cost is not so much there. The work now comes about because you're changing things that were not there.
Maybe also to add on that is that the usability of the place is nullified.
Yeah.
If you have the example of Coco, whereby the place was being shut down altogether because it is affecting them, so because of the acoustics, whatever the guidance was not factored in. And then again, you mentioned the issue of the school. Again, the space is unusable. People cannot listen, cannot hear each other. Students cannot, this conversation cannot be held. So here is your asset that is actually useless. Millions of shillings that are actually useless. What use of it?
I wanted to add on, if you look at, on this, just look at, for example, projects which have been done at the whole sense, I think. Look at when they built what are now meeting. Whatever was happening in one room should not be happening in the next. And they went out of their way to use a specific stone, which is part of the stone that was used to build the pit. Whether it was a gray stone, I don't know what it's called. But it's a specific stone. So it costs them a lot of money. But the value that they're getting out of it is that you can actually sit in a room and have a conversation, and it is within the confines of those rooms. So I think there's that aspect of material management that needs to be put in, whereby even as you're building, so that now your watch is not hearing what you guys are doing in the bedroom, whether you're fighting or having sex. So both.
Yeah, or both. Maybe I can give an extreme example. There was a club called HQ on Langata Road. Yes. HQ. I'll tell you what the story of HQ. When the club started coming up, still at ground level, the architect happened to be one of a classmate. It's our year. No, in your in campus. So he was told by a friend of a mutual friend, have you thought about, have you factored in any acoustics? So he came, actually he got quite concerned, so he came and looked for me. Now he told me the problem I have here is this was not on the BQ. And now I can see there's a problem. I didn't know there's anybody who does this, but we're in trouble. But look, as a pal, so you've not gone far. What can you afford? So we agreed on something. We told him, since you're the one in trouble, so he managed to get a budget for me and say, the owner, when he told the owner said there's nothing like that. He's not going to pay for papers. Because that's what, So, okay. So that ended there. Now, unfortunately for her, first of all, I told her the mistakes were glaring from the ground up. There were very large windows. So I was asking, which disco have you seen with windows? You know, you go to Florida, and it's a disco with windows. I told her, actually, this one is that this thing's going to fail. Anyway, they went ahead and built the place. Unfortunately for them, behind there, a block of flats came up. The block of flats are owned by a man called J.G. Mwangi of Peak Performance. So now his flats, his people are emptying, are leaving his flats because of this club. So the matter was taken to court. Now, that lady was shocked. She found me there as an expert witness on the other side. And the place was shut down. So that, so you can see the real consequences of not.
Let me just chip in on a question German writers have raised. If you allow me, Chairman. The issue of standard with caps. And historically, if you see what happened with gas cylinders, Jacob, Raila Amolo Odinga was fabricating gas cylinders, and you correct me. And also, was fabricating gas, but there was no Kenyan standard. So what did he do? Him and his colleagues went in and formed or wrote basic standards. And at the time, I think he was also employed as a kept. Right now, also working in kept. And that is the standard. And they wrote a whole code of standards relating to the manufacture of gas cylinders. That's why they still refer to as American. And that's the business plan that runs till today. So it's an opportunity here, Jackie, as a leader, as a pioneer in the sector of acoustics, that we challenge you to take the. If I could actually add on to that, what I was involved in development of both the concrete roads and the concrete roads. And what we are having said is a technical committee which just needs you and maybe one person. Then you get a lecturer from the university, one of the guys. The three of you will be able to form a technical committee, but the rest are ministry guys and kept. Then you now can dictate and decide what to be put in. And James is nobody may amiable to new places because it's also one of the key performers. It's a bit tedious, but it's not that because you do most of the donkey part. You make it you have the knowledge. So it's an area that will help the country. It's part of your CSR. Legacy.
Yes, anecdotal evidence suggests that even though there has been no formal standards, that many years ago there was an appreciation of acoustics in Kenya.
Yes.
If I can just give you the older people here, all of them, we used to have something called a nightclub license. Yeah. And these entertainment spots, those particular ones could actually operate the whole night. Yeah. And they could have even, they have music as loud as they want. But even when you are paying to go in, you couldn't hear it. You could not hear it. Absolutely. There was sound back there. Yeah. And there were also only licenses for operating commercial, what you call commercial centers. Now, fast forward today, and we have never trying to run around in a sound meter in an open space, trying to measure sound about where people have been allowed to play music, and they are trying to suppress the music. And between you and me, I think it's not possible. So we just splitting hairs, and I think my view is what has happened is commercial imperatives and also the way we run each other has diminished. Whereby we don't care. So long as my business makes money, the neighborhood can fight all they want, and if they can fight for 5 years and God has made enough, then I can leave it to somebody else. Even the churches, you go through the churches, the older churches, some of them were in residential areas, and they were not really impinging on the neighborhood. But some of the churches put up today are doing that. So, and mosques.
4:30 in the morning.
Yes.
So, back to what Chabela said, and back to your HQ case. What has happened? Why that lady chased you away, basically, saying that why you changed the design, is because over time you change the use of these spaces. Right? Is the still going to be a disco or is it a restaurant? Now, around the time guys like HQ are coming up, why not maybe have big windows? Is because by day it's a restaurant, by night it's a disco. So when you're telling her remove the windows, she's saying, what do you mean? Who come to a dark restaurant? So there's a problem about what you're building, whatever unit it is for.
Remember, now to remember, for those who again, for the legends here, who went to Silver Springs. Where was the disco? It's underground. And that's why you find it does not interfere at all with the Green Hills area. Underground.
Choices.
Yes. Yes. All those were built around that. Yes. Yes. So, and that's why you see, I think there's something we've been talking with Mary Alon, I keep telling him. I'm building one of the things I'm looking at is basement entertainment. Now you remove that whole problem because it's cheaper to go down than to try and reinforce them. You're going to have entertainment, proper entertainment, loud home theaters and the parties, basement. And a lot of that in the West, a lot of people do that.
We also have a size of this room. This big
Zigzag. Zigzag. Yes.
Just thinking about my chart.
Yeah.
Yes. There's something observed. You see that when there's quite a scene, when you listen, very clear, but actually they're loud. But you are outside, you don't get that noise. But there's no nothing on the wall. Not that there's some.
The old churches were very well designed. The design was because there's an entire when you're doing acoustics, like you are doing a church project, there's a specific book acoustic for churches. It's not now you pick a chapter from. A lot of these things are very specialized. Whether it's churches, whether it's studios, so it's a very specialized. Now the people recognize that, and I think there's a project again we were looking at one point where it was one of our colleagues in Yamadenge was building a church and came and asked me, this church, do we need to consider anything? And I told him you have to be very careful because I gave him a copy of a document for the Catholic Diocese of Ohio, Columbia. The instructions on how you build a church, the acoustic document specification. That is an entire place. So there are people who are very serious about it. So I was telling him, just take this is for the Catholic Church, an acoustic specification of how to build the church. So around the world, a lot of this has been done, and people conform. There's nothing new you're doing, and if you do it the correct way.
It's something technical you mentioned. You mentioned the one we back.
Yes.
And with respect to churches, you also say that when it's a Catholic Anglican Chile,
Yeah.
the reverb is X.
Yes.
And when it is Pentecostal,
Yeah.
the reverb is Y.
Yes.
Just tell us what is reverb and then why are they different for the same word?
Okay. Yes.
The Colosseum.
Yes.
It's bigger than Kasarani.
Yes.
But they didn't have loudspeakers.
Yes. Yes.
I think it's in line with the reverberation story.
Yes.
So let's hear a bit more of that science.
No. Reverberation is, as I told you, the basic idea behind reverberation. When you have an enclosed space like this, sound will bounce off the various surfaces until it dies away. So if this place was just concrete all around, it takes a lot longer because you see now the sound bounces a lot longer than if you have absorbent material. Okay. So there are two key things you're looking at: the volume against a function of absorption. This is what we call the coefficient of absorption of any material. You calculate that. Now for churches, why I'm saying churches in particular, there is a tendency to go have high up. The roofs are high. Now, if you put that roof too high, yeah, so remember it's volume over a function of area. Yeah. So if the volume is high, there's a point where there's not much to cut. You cannot even. That's why churches have a very big problem here, because people are looking, I think, at the collection. So you build a very big sanctuary without because there's actually a computation of the volume per congregant. So that you start from there. Because now the problem with churches is that you go to the church and you try and put acoustic materials. One problem is that acoustic materials absorb higher frequencies more than the lower frequencies. What happens? Women can't hear their voices. Who are the people who have been practicing the whole week to sing? It actually affects now. That's why you find the older churches, they don't have acoustic materials, but they are not bad. The acoustics are not bad. They use that they control the river. They control the river by controlling the volume, so that you're not far off. You're building knowing that you want about that. Now, in terms of people like the Colosseum and what, that is one of the things that I was talking about. And you a place like Getty. Those structures up now are still being studied. That's why I started off by saying there was a very clear awareness. I will not be able to give you a straight answer, but the whole idea of having the curves, the parabolic surfaces which reflect back. Yeah. So it's a science that's still intriguing even today. They had an idea that was an issue. Now, yes. So like you find if you have things like clapping, so like the very high-powered services, they need a shorter river, otherwise it becomes muddled. You go to like the Catholic and the Anglican, where you have a lot mournful, even the singing is not. You have mournful services. That's why you need the longer river, 2 to 3 seconds. Yes, then they have the organs. You know the way they sing. And a lot of clapping. But you see you can see the two different types of. So I believe we are drawing the end.
So are you going to form a technical committee?
Yes. Yeah. Oh, yes.
Thank you very much. I wanted to clarify on the issue of technical committee for acoustics. I want to share with you that states has published or adopted quite a number of standards. They could be about 8 or so adopted from the ISO. So it's maybe not an independent committee, maybe it's a committee in architecture, I don't remember. But there is a committee and we have quite a number of standards. You remember I shared with you a few of them. So maybe if you want to join, you just need to write. Yeah, and then they will just enlist you.
Sorry, I stepped out of it. Could you give a detailed example of how you worked on fixing the acoustics for a particular institution. You're not going to mention the name, but have you given the example for them to understand? Given the space that you're in.
Okay, briefly, it starts off with you do an acoustic assessment. If it's a place which has a problem, you're going to look first of all what was the design, or you actually measure using software. You have software, you have your own microphone, and you create signal, and you're able to come up with it's reverb you're looking for, echo. The problems are different. Now you start off from there. So in any project, that's the first thing, the assessment. Then, depending on the solution being looked at, because sometimes end of there, I said this problem is sound insulation between rooms. That's a different problem from river where you want to absorb sound. So those are all different problems. Then there's also noise control. So like a project I'm working on like this one, like at Orchid. That is now noise control. Neighbors are complaining. So all those are different, have different solutions. Now the problem comes in that once I find this is what we probably need to do the acoustic treatments. The problems we're having here is that, and this is something that we've been discussing even with our testing of the materials. We don't have labs that test. So when somebody comes and tells you this thing performs this way, there is no way of knowing whether it's going to work that way. So you find that is a very major problem. So the materials testing is not, you're not getting certified materials. So a lot of projects now start from there. You do the design and then you go back, look at the materials that are available, and then the execution. We take corners, but this is now a specialized area. So if you take corners, you're going to have, like if you're putting a door, if you mess up on a door or glass, you have to redo the whole. So and those materials are expensive. So in terms of projects, those are the kind of challenges we face.
I can say I did something acoustic. I didn't know it was acoustic, but something this was I saw around. And we used as much as I never paid me on my money.
Yeah.
So that was some proving the offices, the meeting rooms, but we're using just plugins. That's what we apply to any other, let's say offices or where people have a confidence or they also have to buy.
You see now, it may work or not. Now, if you're going to do a professional job, you cannot tell the client, we'll test this. If it doesn't work, we'll test something else. You have used now, each material has its own acoustic specification. So, yes, you may put something that works. Yeah. If it works, well and good. If it doesn't work, now that's where your problem comes in. So yes. Eh? No. No. Yes.
Most the churches, like you say, that the only like now we are saying nowadays it's not just the sound we have audio visual, the loudspeakers and all that. A lot of other things. Now when you're designing, you take into consideration what are the some level of by the time you're doing a church and you're doing you take into consideration like that, those like what you're using right now.
Yes.
So you can vary from 0 to 71. Yes. So now I guess that is the don't go beyond
Okay, thank you, Jim. Now there's a cross between architectural acoustics and audio engineering, where you're talking about sound reinforcement. That is now putting the speakers and everything. The biggest problem churches have, they are putting that equipment with bad sound. So it does not matter. You amplify. So if that is just the number one problem. The sound is already bad because you do not take care of the reverb. Whatever you do in that church, you're making it worse. So amplifying the sound is not rarely the issue. In fact, like in churches, You buy the properly designed church, you don't want to put, and you see church has a lot of glass. Yeah. If you design the volume, if you, at the design stage, you have the right ratio, volume, or basically volume per congregant, you will not be far. And if your reverb is correct, then you will not have a problem with amplification. Yes. That is. Yes. 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 That is. So
Just to reiterate, you mentioned there's a challenge at Coco Beach. You didn't give us the results. There was the problem. I don't know what happened. What was the result? Maybe you can.
Well, it was a very challenging project because one of the first things that was there on Coco Beach, first of all, it is a Makuti bar in the middle of an estate. So first of all, from legislative side, it should never have been existed. So even the book I bought has nothing to do with Makuti. There is no acoustic coefficient of Makuti. So there was a lot of learning outside the book. So it was very challenging because of that, and a lot of the work we did revolved around now the equipment and the positioning the equipment. So that is now a part of them. We reorganized all the equipment. We still did a lot of sound proofing, but reorganizing the equipment so that to reduce the ingress of sound from the building. Yeah. So the good news is yes, the project was completed and the club was reopened. But that was a challenging one. Another place that was very interesting was Choices. Remember now when Choices was the original Choices, the cacophony. You leave Choices and people at home are asking why you're shouting. Yeah, because you are still talking at volume length. And all we did at Choices that I did that work, replaced 32 speakers with 4 speakers. The place had 32 speakers. Everywhere you turn is a speaker. And it's also the kind of things where the consultant they get, the consulting they get is from DJs. So you see where the problems begin. So and the supplier of speakers, who is very happy to tell you every corner had a speaker.
Something that is interesting to people. I believe many people love good music, and especially their homes. What advice can you give? How do you do?
Well, now that is more to do with equipment. Sound is about the budget. Let me just say that. It's a budget issue. So you'd have to work. What you ask me, what is the best? You have to now specify within. Because I started off home theaters in Kenya. And I had the first DVD library. That was the number one question I used to be asked. What is the best? So I'm saying best is how much. How much do you have? Then you work backwards. Because there's a lot of information available. So that would have to be on a case by case basis. And again, the room size, and because people now end up finding that you over spec for your space. And the technology also changed now. There's a lot of Wi-Fi speaker. There's a lot of so I'll not be able to give you a specific answer. It has to be against a specific request.
Jackie, I think Chairman, anybody who needs advice, consult.
Yeah. So I think
What I was directing that is that you should give us his contacts. But I'm sure he's going to get quite a number of requests.
So I think the time before I exit the stage, I want to introduce my important guests. Jeff and Sharino have come from Australia, so we have got our first international guests at Marksons. Yeah. All right, let me hand it over back to you. Yeah.
Let's give him another round of applause. Good job done. And I think we have all taken something home. I'm going to share his contacts to the people who are here and also the comment session. Because I think we all need the kind of services that he's offering. And so far, he's the only one who's offering that service in Kenya. So thank you again. Jeff and Charlene, welcome to Chicken Gate. We are a group of upstanding gentlemen who share chicken every Sunday. So we eat chicken 52 Sundays a year. And as much as it's not a Sunday, today we start with the normal nyama choma, then tomorrow we come for the chicken. And for the rest of the attendees, I want to thank you again for making the time. Those who are also online, I would like to thank you. And after this, let us all congregate downstairs to enjoy the boozy that Michael again has sponsored. Thank you again. And with that, I would like to welcome every member who is here today to say one or two. They might go around. Let me start with this side. Was
Good afternoon. Mine is to thank you for organizing this event. The second one, I'd like to thank you for a very interesting talk. Sorry, my name is Anthony. I'm a member of Chicken, member also of Marksons. Thank you very much. Right, my name is KT. This is very good. It goes into the place called Department of Useless Information. That's what Jackie sends me. Good
afternoon, everyone. Gary Amos is my name. I'm an advocate, and it's been nice listening to that presentation. It's an eye-opener. I think one of the members said, I think it's a very problem to have legislation around it because the kind of noise pollution sometimes is complained of not even legislated. Thank you very much.
Thank you all. Thanks a lot for having us here today. I've known brother for a very long time. Still found this very interesting. Have there with this where you're looking at career development, sharing knowledge, very interesting.
My name is Dr. Tuku. I'd like to thank Chairman for putting this together again today. I think that's very informative. I'd also like to pick up that to thank our host from Nigeria, because even prior to this lecture, we managed to put together this list. I'm sure you can hear, you cannot hear each other without the use of this mic. I'm sure you cannot hear. That means they are natural acoustics. So, kudos for getting the river. I'm the host, one of the hosts for Chicken Beach. Model, so make sure you show up.
Good afternoon, everyone. I am John Jacob, and Marksons. Job well done, Tia and Jim. Thank you for a great presentation. You know, it's our second to have that project. So, keep looking forward to the partners. Thank you, sir.
Welcome, everybody. My name is Javier. Thanks to our host, Later, the work we do to consulting and looking at that to do, fill out the So I think I don't have to say, I think a lot of these problems going on, sound, class, or equipment, it looks like we don't have the history at the moment. It needs to be taken up to because a lot of these things is handled by the environment. Proper job because I think a lot of the need just use that allows to suppress what is happening. I think in my time we did all this. And the other thing is that I think this process needs to be released and like issues that we can expect in equipment. And as we get more data, we find that these problems are growing very quickly. And I think we need to address them. Thank you.
First, I'd like to apologize for coming late. In the late session, we end up seeing the people who don't listen to their things advice, their people end up in our offices to hearing problems. So, if you don't listen to you, you come see me.
My name is Engineer Dog. I'm a civil engineer by profession and Acoustics for the members. I'd like to thank my friend Hakeem for